Hi, my name is Amy Ferrer, and in this presentation I will be introducing the topic of Cobb-Douglas utility functions, what they are, how they are used, and when it is appropriate to use them. But first I should give some background information as to why they are used. Cobb-Douglas utility functions are designed to be used in economics to represent preferences. Namely, it outputs the number of utils a bundle of goods has, which is a unit of measure that is useful in assigning a value to bundles of goods in order to rank them in order of preference. Although it is given that it is used to determine the hierarchy of preferences, the number of utils each preference is assigned does not provide any information as to how highly a good is desired, nor does it tell us anything about the relative desirability amongst bundles other than where they lie in the ranking. So, for example, if we have two bundles, bundle A that is comprised of 2 apples and 3 bananas, and it has a utility of 10, being 10 utils, and bundle B that is comprised of 1 apple and 5 bananas, it has a utility of 5, being 5 utils. Their utility values only reveal that bundle A is preferred to bundle B, and it does not suggest that bundle A is twice as good as bundle B, even though bundle A is assigned twice as many utils. So in other words, this means that the nature of utility functions is ordinal, meaning relating to its position in a series, rather than cardinal, where instead it would provide information in a specific direction. It is also critical to understand when to use the function, because Cobb-Douglas utility functions are only good at representing well-behaved preferences. This means that they must satisfy 3 conditions: completeness, transitivity, and the assumption that more of a good is better, usually. And I say usually because for the purposes of this presentation, we will stay true to assuming that the consumer is acting in a way that economic theory can predict. So going back to the 3 conditions, completeness refers to the assumption that the bundles under comparison are equitable choices where a decision can be made about which is better. So in other words, it must make sense to state that one is better than the other or that they are equally desired. Transitivity refers to the logic that their desirability remains consistent with their ranking. So for example, if red cars are preferred to black cars and black cars are preferred to blue cars, then it should follow that red cars are also preferred to blue cars. And of course, we also make the assumption that consumers will always prefer more of a good rather than less. However, it is not a tool for describing all preferences, and it should not be used to represent perfect complements or perfect substitutes. So perfect complements in the economic sense refers to goods that are only useful in conjunction, and if any one of the goods were to be acquired in isolation, would otherwise dissolve it of its desirability. So for example, I would only want to buy ink and a printer together, and either on its own would be entirely useless and therefore would not make sense to purchase. On the other hand, perfect substitutes refers to 2 different goods that are completely interchangeable and leave the consumer just as well off no matter which one of them they choose. So one of the easiest real-world examples of this is a standardized product like milk, where generally a consumer would be indifferent to whatever brand they choose. Technically, they are choosing between different products, but the consumer will receive the same level of satisfaction regardless of which one they choose. Moreover, we cannot talk about Cobb-Douglas utility functions and not address how they manifest into a graphical form. So as you would imagine, these functions are also used to graph the ranking of consumers' preferences as a visual representation. Here is an example of an indifference curve that was provided to us in our digital textbook of the ordinance of sandwiches versus burritos. So when extracting information from an indifference curve graph, it is critical to understand that each and every bundle that leaves the consumer just as well off will lie on the same indifference curve, and any bundle that ranks higher or lower in terms of preference will lie on a different indifference curve. In this graph, there are 3 characteristics that are representative of the 3 conditions necessary to satisfy the justification for the use of a Cobb-Douglas utility function. The first of which is the downward slope of the curve, which indicates that in order to increase the consumption of one good while maintaining the same satisfaction level, the consumer must decrease the consumption of the other good. And this is due to the fact that consumers will always prefer to consume more goods rather than less of them. The second characteristic to note is its convexity to the origin. And this is representative of the assumption that consumers prefer a variety of goods over a singular good. Lastly, because all Cobb-Douglas functions must obey the set of assumptions that we've made about consumer preferences, it follows that indifference curves will never cross because of their ordinal nature. This is a visual manifestation of the transitive property of indifference curves. Now we can actually go over the actual functions themselves. The general form of the Cobb-Douglas utility function is as follows. In this function, A and B are constants, and x and y are greater than 0, which also means that there are no x and y intercepts. Here is an example of what the function could look like. However, we will often transform this function by taking its natural log, which also allows us to transform exponents into coefficients, which is particularly useful when performing linear regressions. This is also called normalizing, and it makes it easier to find the marginal rate of substitution, or MRS for short, which I will go over in the next slide. When we take the natural log of the general form of the Cobb-Douglas utility function, it looks like this. To normalize a Cobb-Douglas utility function means adjusting the exponents so that they sum to 1, typically by dividing each exponent by the total sum of all exponents. And this doesn't change the consumer's preferences, but simplifies analysis, which, especially in budget allocation problems, is useful. So when it's normalized, the exponents directly represent the proportion of income spent on each good, making interpretation and demand derivation more intuitive. So here is a simple example of the normalization of the Cobb-Douglas utility function, where the exponents add up to 6. And we can then divide each exponent by the total sum of exponents, and we are then left with a normalized function. This can be translated into words by saying that the consumer in this case spends 2/3 of their income on good X and 1/3 on good Y, assuming prices are constant, and it simplifies budget allocation. If a consumer has $90, then they would spend 60 on X and 30 on Y. So as promised, I will now explain the marginal rate of substitution, or MRS for short. It is the ratio of marginal utilities of the goods in question, which refers to the additional satisfaction a consumer gets from consuming one more unit of a good, holding everything else constant. So if you consume one more apple, then the extra satisfaction you get from that apple is the marginal utility of apples. The function for marginal utility looks like this for x and for y. The ratio of marginal utilities is also known as the slope of the indifference curve, which looks like this. In conclusion, Cobb-Douglas utility functions are a powerful tool in microeconomic theory for modeling consumer preferences under the assumption of well-behaved, continuous choices. By capturing the trade-offs consumers make between goods through utility, marginal utility, and the marginal rate of substitution, these functions provide both analytical clarity and graphical insight. While they are not suitable for every preference type, their structure makes them especially useful for studying balanced consumption decisions and predicting demand. Thank you.